So in the miscellaneous exercise 9 up to 15 we have discussed. We go to question number 16. There you are given that a into 1 by b plus 1 upon c, comma, b into 1 upon c plus 1 upon a, and c into 1 upon a plus 1 upon b are in AP. This much we are given. And what we want to show? We want to show that A, B, C are in AP. So here one way is this. You are given that these three terms are in AP. It implies this minus this, that is B into 1 upon C plus 1 upon A minus A into 1 by B plus 1 upon C. This minus this equals to this minus this. C into 1 upon A plus 1 upon B minus B into here 1 upon C plus 1 upon A. The difference of this and this equals to this minus this. That's what I've written. Now you just simplify this expression. At the end, you want to show that A, B, C are in AP. That's what you want to show. It means after the simplification, you must get B minus A equals to C minus B. That has to be the simplification of this. So try, just simplify this, you must get this. And once you get this, you can immediately conclude that the A, B, C are in arithmetic progression. That's the one standard way. The another way of doing the same question, you can do like this, or if you want to do, you can do like this. What I'll do, let's write this. You are given that A into 1 upon B plus 1 upon C, B into 1 upon C plus 1 upon A, and C into 1 upon A plus 1 upon B are in AP. That's given to you, are in arithmetic progression. Okay. Now here let me just open the bracket here. So A by B plus A by C, comma, B by C plus B by A, comma, C by A plus C by B are again in AP. These terms are again in which progression? Arithmetic progression. I did nothing. Now terms are in AP. If I add plus 1, again these terms will be in AP. I'm just adding 1. Now here instead of 1, I'll write here, I want A, B, C. So I'll write A by A. B by C plus B by A. I need here B. So I'll write B by B. B by B is just 1. C by A, C by B plus instead of 1 I'll write C by C, which are again in arithmetic progression. These terms are again in arithmetic progression. Now what I'll do, I'll take A common again and I'll take LCM. So LCM will be ABC. What I'll get here? B is there, so this is AC, C is there, AB, A is there, so this is BC. Same thing I'll do here also. I'll take B outside, ABC LCM. Here same thing, C is there, so AB plus BC plus CA. Just observe, I'm taking LCM. Take C outside, ABC LCM. Here again you will get the AB plus BC plus CA. These are again in which progression? Arithmetic progression. Okay. Now this AA will get cancelled. This BB will get cancelled. CC will get cancelled. You can divide by AB plus BC plus AC. Just dividing by this. So we'll get the 1 by BC, 1 by AC, and 1 by AB are in arithmetic progression. These are also in AP. And now multiplying with ABC. So ABC by BC, ABC by AC, and ABC by AB are again in AP. Multiplying with some constant, it remains AP. BC will get cancelled. AC will get cancelled. This is B. And CC will get cancelled. Here ABB will get cancelled. So we'll get the C are in arithmetic progression. This is another way of doing the same question. If you feel that this is easier, you can do like this, right? Otherwise, this is another way of doing the same question. Question number next 17. There you are given that this is 4 terms are in geometric progression. Let ratio be ratio equals to small r. Therefore, small b you can write obviously first term into common ratio. C you can write as previous term into common ratio. But b is nothing but ar, so this is ar square, that you know. This b, and what will be d? It would be obviously fourth term, so it will be a into r cube. So these are the values of b, c and d in terms of a and r. First term is already a here. Okay, what you want to prove? We prove that these 3 terms are in geometric progression. We prove a raised to n plus b raised to n, comma, b raised to n plus c raised to n, comma, c raised to n plus d raised to n are in geometric progression, are in GP. So what you need to do? You know now, as we did in the previous question, AP question, you get the ratio. You find these upon this. And you find these upon this. You should have the same ratio. That means these 3 terms are in geometric progression. So I'll start with this. B raised to n plus c raised to n upon a raised to n plus b raised to n. We find this ratio. And then these upon this, we'll notice that both the ratios will be same. What we do? We just put the values of b, c, and again b in terms of a and r. Let me put here, what is b? That is ar. So ar whole raised to n. What is c? ar squared whole raised to n. What is a? That we keep as it is. What about b? Again ar the whole raised to n. You will see that here, you can see, you will find a raised to n and r raised to n common. So what I'll get here? Just 1. This is r raised to 2n, so we're left with r raised to n upon. Here I can find a raised to n common. So what I'll get inside the bracket? 1 plus r raised to n. This will get cancelled. A raised to n will get cancelled. So what we are getting? Just r raised to n. Call this as 1. Now in the same way, what we'll do is here, in fact that I leave it for you. You start with now this ratio. Which ratio? D's upon this. C raised to n plus d raised to n upon b raised to n plus c raised to n. Put the value of c, d and b here in terms of a and r. Simplify. You will see that this is again r raised to n. So from 1 and 2, what's the conclusion? From 1 and 2, you can say that these terms are in the same ratio. Therefore, these and this are in geometric progression. Fine, not a big task, just simplify. You will notice that the ratio would be same. Next question. You are given a quadratic equation with these 2 roots. So therefore, sum of the roots, you know, a plus b minus b by a. It will be 3, and the product of the roots, that is ab, which will be small p. You just recall this much from 10th standard. If ax square plus bx plus c equals to 0 be the equation, alpha beta be roots, then we know that sum of the roots alpha plus beta is minus b by a. And alpha into beta, that's the product of the 2 roots. It is given by c by a. We know this. I've used this minus, and this minus gives us plus here. So we have here plus 3. So one is this, second one is this. Here same condition, c and d are roots. So c plus d equals to minus 12 by 1 with minus sign. So this is 12. And product of the roots, it will be q. Fine. We have these two things. Okay. We are also given that these four terms are in geometric progression. A, B, C and D are in GP. So like the previous question, I'll assume that the common ratio equals to small r. So therefore B you can write as AR, you know very well, first term into common ratio. C we can write as previous term into common ratio, so we'll get AR square, we know it, and D will be obviously being fourth term ARQ. So we have these values. Okay, now we just get into that required ratio. We want Q plus P upon Q minus P. We want this equals to 17 by 15. I'll place the value of Q. What is Q? You know it is CD here. What is P? It is AB here upon CD minus AB. Now we just place the value of what? C, D and B from this. So C into D, that's a product of these two, which is A square into R raised to 5 minus A into B. A we keep as it is, so this is just A square R. B is AR. Now in the here we have plus, now we are going to write just minus sign here. Same thing but with minus sign. What is common? You will find A square R common. So this is R raised to 4 plus 1 upon, here again A square R you will find common. So this is R raised to 4 minus 1. This will get cancelled here. Now ultimately question comes to, you need to find the value of R raised to 4 and we put here. So for that what we do is, we have not used this information, we'll use this. So let me do this much in a side here. So as A plus B is 3, it implies A as it is, what is B? AR equals to 3, and C plus D equals to 12. You must have noticed in the entire solution we are converting everything is in form of A and R. It implies what is C? That is AR square. What is D? AR cube equals to 12. Now if I use this 2 and I'll take the ratio, let me call this as 1, 2. I'll just take the ratio here. So ratio of 2 and 1. I'll take AR square common. So here 1 plus here what we'll get? If I take AR square common, this is 1 plus R upon, right hand side is 12 upon, I'll take A common here. So 1 plus R by 3. Is this clear to you? I've just taken the ratio. A will get cancelled, this will get cancelled. So I'll get the R square equals to 4. We'll put R square equals to 4 here. So what will be R raised to 4? We have put R square equals to 4 here. This will be 16. So 16 plus 1 upon 16 minus 1. So what we'll get from this? This is 17 by 15 and hence proved. Right? That's what you wanted. It's a simple algebra. You have used all relations. You have used this and so on, and you converted everything in form of A and R. Fine. Question number 19. You are given that the ratio of arithmetic mean and geometric mean of two positive numbers. Okay, so we are given that arithmetic mean upon geometric mean equals to m by n. Right. But We know arithmetic mean is this a plus b by 2. And geometric mean we know it is root ab equals to m by n. Right? Geometric mean we know for two numbers it is root ab. Arithmetic mean we know for two numbers is a plus b by 2. That we know very well. Okay. So we have this. So this is just same as a plus b upon 2 root ab equals to m by n. Now we had earlier such two questions. If you just refer exercise 9.3, have a look at question number 28 and 29. The flow of solutions of these two questions is more or less like the flow of this solution. So what we'll do here, if you just recall these two solutions, I'll do this a plus b plus 2 root ab. Why I did like this and what I did, that's the next question, a plus b minus 2 root ab. Can you recall componendo and dividendo? M plus n upon m minus n. We did this in these two questions, CD rule, componendo and dividendo. If you have x by y equals to let's write here a by b, then it implies you can do x plus y upon x minus y. Componendo means you are adding and dividendo means you are subtracting, equals to a plus b upon a minus b. Same thing should be done on both the sides. You have added, you have added. You have subtracted, you have subtracted. That's what I did. Why I did like this? Because now you observe the numerator. Numerator is a perfect square of what? Root a plus root b the whole square. What is denominator? It is root a minus root b the whole square equals to m plus n upon m minus n. What you want, that should be there in your mind. You want ab. Okay. I'll take the square root. Root a plus root b upon root a minus root b equals to root of m plus n upon root of m minus n. Just taking square root. Fine. Now what we'll do? Again, if you just go back to these solutions, I'll add these two. If I add these two, it will be twice root a. What I did, I've used this again CD rule. Now I'll subtract. We'll do this minus this, so it will be 2 root b. And same thing should be done here. Root m plus n plus root m minus n upon root m plus n minus root m minus n. What I did? Same reason. Componendo and dividendo. CD rule. Fine? Okay. Now this 2 will get cancelled. You are interested in a by b, so we just square it. So a by b equals to, you square this, the whole square. So a square, so m plus n, b square, it will be free from the square root, plus twice this into this. So it will be m square minus n square upon this square plus this square, m plus n plus square it, so m minus n minus middle term, 2 times this into this, that is the root of a plus b, a minus b, a square minus b square. What I did? By squaring, you can write here, just squaring on both the sides. Why we have squared on both the sides? Because I don't want root ab, I want just ab. Okay, so a by b equals to, n will get cancelled. This is 2m plus root twice m square minus n square upon n will get cancelled here. 2m minus twice root m square minus n square. So you cancel 2 from both. So you'll get the m plus root m square minus n square upon m minus m square minus n square. We have this and therefore proved. Right? So you must have noticed the flow of the solutions of these two and this all are just same. In the 20th question, you are given number of things. Let me write first. So first thing is A, B, C are in AP. A, B, C are in arithmetic progression. So you will get 2B equals to A plus C. You know, twice of the middle one equals to sum of the other two. Call this as 1. Why this? Because of this difference is same. B minus A equals to C minus B. So we'll get the 2B equals to A plus C, which I wrote directly here. Okay, and what the second thing you are given? B, C, D are in geometric progression. B, C, D are in geometric progression. So your square of the middle one equals to the product of the other two, always true. Why this? Just for your information. This by this equals to this by this. So C square equals to BD. You can write directly whenever three terms are in GP, square of the middle one equals to the product of the other two. Whenever three terms are in AP, twice of the middle one equals to sum of the other two. Okay. And one more thing you are given also. Third thing you are given, that is 1 upon C, 1 upon D and 1 upon E are in AP, are in arithmetic progression. So again, twice of the middle one, 2 into 1 by D equals to the sum of the other two, 1 plus C plus 1 upon E, because of AP, 2B equals to A plus C. Twice of this equals to sum of these two. Okay, so we have these three things, this and this. What we want? We prove this, or what you are asked to prove, that A, C and E are in GP. This is what you are asked, are in geometric progression. So what you need to prove? C squared equals to A into E. This is what you need to prove. C squared, the square of the middle one equals to the product of the other two. This is what you need to prove. So what you need to do in entire solution, I just give you the hint. Use this 1 and 2. Place the value of here D. D will be in terms of what? C square by B. Place here. And you can use the value of B also and simplify. Immediately you will get this. Right? Again, use 1 and 2. Place the values in third one and simplify. You must get this. So try it. Okay, you can do it. I leave it for you, I'm sure. Not a big task. It's simple algebra. Okay, question number 21 next. We had earlier such questions. We have discussed. I'll go to second one. You know how to do the first one. If I just give you the reference, refer this question number 18 from exercise 9.3. You will realize just similar question. So here both are just same. I'll get into second one because that's about decimal point, which also you can do once you solve this again. And if you do the first one of this one, second one is again not a big task for you. But still let me do it just for you. Sum of n terms Sn, your 0.6 plus 0.66 plus 0.666 and so on, for how many terms? N terms. Now what we do normally for such questions, I'll take 6 outside. So what we'll get here? 0.1 plus 0.11 plus 0.111 and so on. Okay, now you know what is to be done. Always we convert into which form? 9 form. So just multiply and dividing by 9. So here your 0.9 plus 0.99 plus 0.999 and so on. For how many terms? N terms. Okay, then we'll convert in terms of what? 10, you know. So this you can just write 2 by 3 outside. 0.9 you can write as what? You know this, you can write 1 minus 0.1. 1 minus 0.1 plus what about 0.99, which is nothing but 1 minus, you can write, this is actually 1 by 10, so you can write 1 by 10 the whole square, which is 0.01. You can just check it out, and so on. Fine. This is 0.1, this is 0.01. 1 minus 0.01 is 0.99. Now what we do, we write 1 1 1 how many times? N times. 1 plus 1 plus 1 how many times? N times, because you want to add n terms. Plus, sorry, here minus, what about the other bracket? 1 by 10, 1 by 10 square, then 1 by, obviously next term has to be 1 by 10 cube and so on. Now why we did this, you must have noticed, because this is neither AP nor GP. We can add the terms only when it is either AP or GP. So by this procedure you converted, this one is just simple addition, 1 1 1 n times. What is that? That is n. But this became a geometric progression. This is nothing but which progression? Geometric progression. This is GP. What is the first term here? 1 by 10. Common ratio, again 1 by 10. So here A is 1 by 10. How do you get the common ratio? These upon this, which is 1 by 10. So you can add the n terms here. So here, if I rewrite, this is equals to 2 by 3 outside as it is, small n as it is, 1 1 1 n times. Now you are adding n terms of a geometric progression. What is that? A. What is A? 1 by 10. A into r raised to n, yeah, 1 minus r raised to n. Okay, 1 minus r, 1 by 10 the whole raised to n, upon 1 minus 1 by 10. Have you realized which formula I've used? Which formula I've used? A into 1 minus r raised to n, if you remember, upon 1 minus r. You can write r raised to n minus 1 upon r minus 1 also, remember, sum of the n terms of a geometric progression. So sum is almost over. Now we'll just simplify. What is this? This is 1 by 10. This is 9 by 10. Right. So 10 10 will get cancelled. Here we are just left with 1 by 9. 1 by 10. This is how much? 9 by 10. So this is just 1 by 9. 1 minus, what is this? This you can rewrite as upon 10 raised to n. So this is 10 raised to minus n. If you want, you can take just 2 by 3 inside this. So I'll get it here, 2 by 27 into 1 minus 10 raised to minus n. This is the required summation, sum of the n terms of a given progression. The next question, you are given a series here, this like a1 plus a2 plus a3 and so on. So we write nth term. So we write an first here. Now we did such things in earlier exercise. You see this is 2, 4, 6, all are even numbers. So it will be 2n into, now 4 is nothing but this number plus 2, 6 is nothing but this number plus 2, 8 is nothing but this number plus 2. So 2n plus 2. This is nothing but the nth term. How we wrote this? Just by observing. I repeat, this is 2, 4, 6. What are these? Even numbers. Even numbers means 2n. Now what about next number? 4 is this number plus 2. 6 is number this number plus 2. So what I did? This number plus 2. Now what you want? Once you do this, you can answer any number of terms. This is nth term. You know this is which term? Nth term. This is a general formula. You are asked for 20th term. So put n equals to 20. So 2 into 20, which is 40, into, what is this? 40 into 40 plus 2, which is 42. So this would be finally 1680. That's required term here. Important one is this an, and then just we have placed n equals to 20. Next question, it's like previous question only. You are given a series here, 3 plus 7 plus 31 and so on. But here, like previous series, all the terms are not like in product, so it's difficult to predict nth term. So for such questions, you can do like this. What I'll do, let this be Sn, because this is some of the n terms of the series, 3 plus 7 plus 13 and so on till nth term. Now again I'll write the Sn like this. I'll just start from here, 3 plus 7 plus 13. This is here last term, so this is a second last term, and here your last term, which is an. This is an in fact, and this is an minus 1, previous term. I've shifted towards right. Now we subtracting these two, so I'll write here subtracting these two equations. So Sn minus Sn gives us 0. 3 minus 0, which will be 3. Term wise we are subtracting. Nothing means 0. Plus this minus this, it would be 4. This minus this, it would be here 6, and so on. Till this which term? Here, this is n minus 1th term, right? So I'll write here n minus 1th term. And here nothing means 0, this minus this, so you have minus an. Fine. What I did, I have just subtracted terms. This minus this, here 3, 7 minus 3, 4, 13 minus 7, 6, and so on. Similarly, this minus this, whatever it is, but it will be the second last term, and this will be the finally last term. Fine. Now here you take minus an on this side, so this is an, 3 as it is. What is this? This is arithmetic progression. First term is 4 and the difference is 2 here. This is AP. I'll write here with A equals to 4 and common difference equals to 2. So you want to add how many terms? Here n minus 1 terms. So which formula? If you remember for AP, the formula will be n by 2 into 2a plus n minus 1 into d. This is the formula for sum of n terms of an AP. Instead of n, you have how many terms? N minus 1 terms. So n minus 1 by 2 into 2a. So 2 into 4, which is 8, plus here instead of n you have n minus 1. So n minus 1 minus 1 into d. What's d here? 2. Fine. 3 as it is. For this middle n minus 1 terms, I've used the summation formula for AP. Minus an I've taken on the left hand side. If you want to just refer example number, illustration, example number 19. It's the same example. Illustration number 19 of the textbook. You just refer, you will realize. It's just copy of this only. Okay, so therefore an equals to 3 plus, now we'll simplify this, n minus 1 by 2 as it is here. What about the bracket? If you simplify the bracket, it will be just 2n plus how much? 4. Okay, so 3 plus n minus 1 into, take 2 common, it will get cancelled. So here n plus 2. So 3 plus, this is n square, this is plus n here, and minus 2. So we'll get the n square plus n plus 1. This is an. So finally now we got the nth term formula. In the previous question you were getting directly, just by observation. We could write the nth term formula directly. Here from the observation it's difficult to predict. The nth term will be n square plus n plus 1. Now you can verify. Put n equals to 1. 1 plus 1 plus 1, 3. Put n equals to 2. 4 plus 2, 6 plus 1, you see 7. Put 3, you will get the 13 and so on. So this is the standard way of doing this Sn. Rewrite like this. Do the subtracting. Leave this first term and the last term alone. Subtraction of this many terms only. Middle terms, this one and this one. This will be n minus 1 terms. This would be always standard AP or GP. Okay. Now what is asked in the question? So you got the formula for an, right? So what is asked in the question? Find the sum of the first n terms. Once you get the an, so you will get the required summation equals to what we do now, as we were doing in one of the exercise. If you remember, sigma, you can write here ak, where k runs from 1 to n. This is Sn, remember, required summation means Sn. So sigma k runs from 1 to n, ak means what? K square plus k plus 1. Take the sigma inside. This is k runs from 1 to n k square. The sigma k runs from 1 to n k plus sigma k runs from 1 to n1. Fine? You know this is nothing but which exercise? Just recall exercise 9.4. We had number of such questions. What is this? If you remember, it is n by 6, n plus 1 into 2n plus 1. What is this? N by 2 into n plus 1. You know this. 1, 1, 1, how many times? N times. It is n. Now you just need to simplify this, right? This is sigma k square formula. You know it. N by 6, n plus 1 into 2n plus 1. The sigma k formula, n by 2, n plus 1, 1, 1, 1, n times. So question is just simplify and check your backside answer now. Question number 24 here. 24 question. What is given? S1 is the sum of the first n natural numbers. So it is 1 plus 2 plus 3 up to n. You know this. We have used just now. It is nothing but n by 2 into n plus 1. Here it is. What is S2? That is the sum of the squares. So 1 square plus 2 square up to n square. S2 is this. What is this? As you have written here, n by 6, n plus 1 into 2n plus 1. What is S3? In the question you are given, it is sum of the cubes. So 1 cube plus 2 cube up to n cube. And what is that? You know, it is the square of the first formula, n squared into n plus 1 the whole square by 4. These three things you are given. Sum of the natural numbers, sum of the squares, and sum of the cubes. Our three standard formulas. Then you are asked to prove something. So what you need to do, I'll not do it. It's very simple. You just start with RHS here, right hand side. Place the values. Place the value of S3. You know it is this. 1 plus 8 S1. S1 you know. Right? Place the value of S3, S1. Simplify. Immediately you will notice that it is nothing but the 9S2 whole square. So it's a square of this. Right? It would be square of this. And then just put on the right hand side. That is 9S2 square. Immediately you will realize both LHS and RHS will be equal and therefore brought. Right? I'm sure this much you can do. The next two questions, 25 and 26, are just based on exercise 9.4. Right? We had number of such questions there. You are asked for some of the following series up to n terms. So given series is this: 1 cube by 1 plus 1 cube plus 2 cube upon 1 plus 3. Third term is 1 cube plus 2 cube plus 3 cube upon 1 plus 3 plus 5 and so on. So what do we do in such questions? As we did there. In which question? If you just go to question number this 22 and 23, get the nth term, and then here you were asked 20th term, so you have placed 20th. In 23rd term question, you have first obtained which term? Nth term, and then you have applied the sigma. So same thing, we find an and we applied the sigma. That's what everywhere we did in exercise 9.4. Okay. So, but here by observation we can write nth term. So an equals to nth term. What's the first term? Here 1 cube. Second term 1 cube plus 2 cube. Third term up to 3 cube. So what is the nth term? 1 cube plus 2 cube plus 3 cube up to n cube. I repeat. You see, in the first term you have only 1 cube. In the second term you have up to 2 cube. In third term you have up to 3 cube. So in the nth term you must have up to n cube. What about denominator? Here 3, then 5. So here 1 plus 3 plus 5. Have you noticed? These are the odd numbers. Which is the last odd number? 2n minus 1. You know. Summation. In second term you have up to two odd terms. In third term you have up to 3 odd terms. 1, 3, 5. So in the nth term you must have up to nth odd number of terms, that is 2n minus 1. Now we simplify this. How will simplify? You know, numerator is that sigma n cube formula. What is that? N square by 4 into n plus 1 the whole square. You know, sigma, it is k cube where k runs from 1 to n. We have used in the earlier example. Sum of the cubes of the first n numbers. N square by 4, n plus 1 whole square. What is this? This is nothing but which progression? You can notice very easily it is nothing but arithmetic progression. How many terms you want to add? N terms. So you can do here n equals to first term 1 plus here you want to add this. So Sn equals to here you want to add n terms. So n by 2 2a. What is a? 1 plus n minus 1. N minus 1 into d. What is d? It is 2. So here you can take 2 common. That will get cancelled with this. Inside the bracket you have just n. So we'll get n square. So this is n square. Sum of the first n odd numbers equals to n square. It is always true. You had this question in PMI also. Show that this is equals to n square. We did by AP. It is summation. So I've used Sn formula. N by 2, 2a plus n minus 1d. A is 1, common difference is 2. Now we simplify. So n square will get cancelled. You have n plus 1 whole square by 4. That is an. Now recall exercise 9.4. Once we get an, required summation, that is Sn, which is sigma k runs from 1 to n. Here k plus 1 the whole square by 4. That 4 is constant, so I'll keep 4 outside. 1 by 4 in fact. And what is this? Sigma k runs from 1 to n. This is k square. 2 outside here. Sigma k runs from 1 to n. K here plus sigma k runs from 1 to n1. Fine. What I did, I opened the bracket, k square plus 2k plus 1. Okay, now you know how to proceed. Write the expression for this, you know it. Plus 2 as it is. Write the expression for this, you know it. This is nothing but about 1, 1, 1. How many times? N times. And simplify. That's your answer. Fine. The important one is how to write an. This up to this, it is important. This is very important question. Fine. Clear? Okay. Let's go to next question, 26th here. In the 26th, I'm sure you can do it now very easily. There you are asked to prove, right? Procedure is same. So in the 26th question, you are given this series 1 into 2 square plus 2 into 3 square and so on, n into n plus 1 the whole square. So nth term is ready for you. You can see. What is this? 1 square into 2 plus 2 square into 3 and so on. Here also nth term you are given n square into n plus 1. Fine. So we write here nth term for numerator, for denominator, and we'll simplify and we'll show this. So for numerator here, for numerator, nth term is this. Which one? You are already given n into n plus 1 whole square. Nothing you have to think. Put n equals to 1, you will get this. Put n equals to 2, you will get this. So this is for numerator. And for denominator, what is nth term? That's already there, which is n square into n plus 1. Fine. So now here for LHS, you need to apply sigma to this because you need the summation. So sigma k runs from 1 to n. Here k into k plus 1 the whole square. You know now, instead of n I wrote k upon. What about this? Sigma k runs from 1 to n, k square into k plus 1 you have. Now how we'll continue as we were doing in that exercise. So you cannot cancel 1k here because summation is there. So here sigma k runs from 1 to n. This is k square, and if I open the bracket it will be k cube. K square and k plus sigma k runs from 1 to n. 2k plus 1, so 2k square. K square will come out and 2 will come out, k square as it is. Plus sigma k runs from 1 to n. Last term is k because we are taking k inside, upon. What about this? Here sigma k runs from 1 to n. Over here this is k cube plus sigma k runs from 1 to n, k square into 1, which is square. Now everywhere you are going to put the expressions. All are standard expressions. And then finally you will simplify. So you must get that required ratio. What is this? You know, n square by 4 into n plus 1 the whole square. This 2 as it is. What is this? N by 6 into n plus 1 into 2n plus 1. Plus, what is this? You know, it is nothing but n by 2 into n plus 1. Upon, what is this? Same, n square by 4 into n plus 1 the whole square. Plus, what is this? Same, n by 6 into n plus 1 into 2n plus 1. Now, simplify this. Take number of things common. Here also number of things common. And finally, after the simplification of the numerator and the denominator, you will get finally this much. This 3n plus 5 upon 3n plus 1. I have just written directly RHS. This much is for you. Simplify. It's a simple algebra, not a big task. So you got the RHS. Up to this term it is important, remember. This is just expressions and you need to simplify. So you'll get the required RHS. 3n plus 5 upon 3n plus 1.